So we made a bicycle class to represent a bicycle object, and we've got the number of gears that the bike is made with. So when you initially make it by a new, it comes in with 15, 20, however many gears. And it's really typical that all the constructor does is record those values that come in so it can make use of them later. Okay. So we got the gears in there, so we made a get gears. There's no set gears because we don't ever want to change the number of gears on the bike. And then we started to get the idea of what else can we do with the bike? Well, the most obvious thing is you can start to pedal the bike to make it go. And when you pedal, the speed increases. And we said it's going to increase by some amount, probably in relation to the gears, but this is good enough for now to say it's at least got to go up. Okay. So we've got pedal in there, and then we said, well, okay, if there's a variable called current speed, then it makes sense that you should be able to retrieve that value so that you can ask the question, how fast am I going? Okay, and that's about as far as we got on the bicycle class. There's a couple of things, a couple of obvious things that are missing here. The first one is what's missing in the constructor. Current speed, what value should it have? So hopefully when you get your bike, it's not moving really fast. So you expect that for a start, it has a current speed of 0. And there's a pretty general rule for you that if you have two variables up here, the constructor should initialize both of the variables. It's just a nice, easy rule. If you have 4 variables up there, you should see 4 initializations. It just makes sure that the constructor knows what it's doing. It's also fairly typical with these classes that you'll get a few variables that come in from the outside world that tell you how this thing is going to look, and you'll have a few variables that regular people don't see that you set internally for a start. Okay, so there's a sample of both there. So gears is provided to you, but current speed you set yourself. Okay, so we've got, we can pedal. What's the opposite of pedal? Brake. Spell it right, I guess. And when you brake, what happens? Current speed decreases. So you can use control space to look at the variables that you can use at this point. So current speed goes down somewhat. Again, in the future, it might depend on how hard you actually hit the brakes. Maybe we'll have some way of saying that. But for now, you know that at the very least, it goes down. Speed goes down. Got it. So there's the start of a bicycle class. We've written a reasonable amount of code. What would be a good thing to do now? We have a driver that we were using to fool with it a bit, but the better thing to do would be to write a unit test and just see whether or not what we have works so far. Okay, so we'll go in and we'll make sure we've selected the bicycle class, and we'll say File, New, JUnit test case, and setup method will include, and we'll figure out what that does later, and we'll do the start of bicycle test. It's going to ask you if you want to add the libraries. The answer is yes. Off we go. Okay, so we're going to ignore the setup. We're going to say here's where we should put our first test. We can go steal stuff from the driver. Here's what we did initially in the driver to make a bicycle. So every one of these tests is basically almost like a mini little driver program to test one little small specific thing. So if I make a bicycle, and we'll call this test initial setup, what do you expect your bike should look like when it arrives from the factory? It should what? It should have the number of gears that you specified, so it shouldn't be a 10-speed bike because then you wouldn't get what you paid for. So let's do gears is talk to my bike dot get gears to find out how many gears that it has. And then it's, I think that the gears should be exactly 21. Anything else you know about your bicycle at this point? It shouldn't be moving. That would be a good thing. So we'll go find out what the speed of the bike is right now. So talk to my bike dot get current speed, and I think that speed should be exactly 0. Okay? You can run the unit test. You've just got one test so far, and that test comes out okay. Okay? So now we know that we got the bike fresh from the factory the way we wanted it. What's another test that we should be able to do? That you can actually pedal the bike. Okay, so let's just steal a bunch of this code because it's useful. So instead of initial setup, it's pedal. And I'm just going to pedal once. I'm going to make a new bike. I don't care about gears anymore because we've already tested that. In this case, what I'm going to do is my bike dot pedal. I'm going to get the speed, and now I think the speed instead of 0 should be 1. Should have gone up. Run the test. Still works. What next? Could test brake. So we'll make our some method brake once. We'll make a new bike. We'll pedal. And then we'll do my bike dot brake, and then we'll check current speed, and current speed should be back down to 0. Does that look like a good test?
The spelling is wrong. That brake.
I did it again, did I? Oh well, spelling won't make a difference. There we go. Anything wrong with the test?
No, would you have to check pedal again?
Because you have to pedal to be able to brake, right?
Okay. I was saying if you were to check.
But haven't you have pedal plus, so wouldn't it increase the original value?
One of the tricks of the trade here is you started to talk about what it did inside. And I'm not interested in what it did inside. I'm only interested in what this thing says it does. So what it looks like from the outside world. Are people going to scratch their head about this test? Is it perfectly understandable, or is it a bit mystifying?
If you didn't know if the pedal already brakes, then you wouldn't know if either can brake, kind of. I don't know.
It's sort of weird that we're doing two things at once, and suddenly we've got a value of 0. And the only reason why we sort of know that it works is because we happen to know what the previous test did. Okay, and we're relying on that to figure out what the current test does. But you have to remember that people who are reading tests are only going to probably read the one at a time. And so this one sort of doesn't make any sense, and the reason it doesn't make any sense is I sort of don't know what the value was to start with, and that's what's a little bit confusing. And so if I just spend a little more time on this test, and I'm going to take this and I'm going to say, well, it should start at 0. If I pedal and get the speed, I now know that it should be 1. And if I then brake, I know that the speed should have gone back to 0. Is that more clear? So yeah, I repeated some of the information from the previous test, and officially I didn't have to. But when I go to read this test, this one by itself now makes a lot more sense. Okay? So this is this clarity rule again. There's nothing wrong with repeating information just to make sure that people understand what you're doing. And now you can go and you can say, hey, well, look, I started out at the speed of 0. I pedaled once. I expect now that I should have gone up to 1. And then I'm going to brake right again because that's all I want to test. And it should be back down to 0. Okay? So that's a little bit of a better test. Okay? And maybe now, once people understand the pattern, it makes more sense to start to take shortcuts. Okay? First few tests, be very careful about taking any shortcuts. So what would you like to do now for a test? When you look at this test by itself, what's the expectation that you haven't checked so far? What's the thing that you expect to happen if you do something here?
Eventually go faster.
Eventually you would go faster. The only thing we know here is that you can get up to a speed of 1. For all we know, it's going to stay at a speed of 1 no matter how hard we pedal anymore. Okay? And the expectation is that it will go 1, 2, 3, 4, 5, etc. to work its way out. So let's do another test that checks that. So I'll just steal a little bit of code here. I'll write another test, and then I'm going to call this speed increases. Okay, so notice how I'm trying to give you a clue of what the idea is. So speed starts at 0. I'll pedal, it should go up to 1. I'm not really interested in braking at this point. So I'm going to try to group these together. So I'm going to pedal, check the speed should be 1. I'm going to pedal again, check the speed should be 2. And then I'm going to pedal again, just to be sure that it goes past 2. Check the speed. So in math, the term is, sort of inductive proof, right? I did the 0, 1, 2 odd cases, so from now on I can assume it probably works. Okay, it's probably going to get past 3. That's a pretty good assumption. So you don't have to make it go forever. You just have to test enough of them to make sure that it's sort of obvious. Before you write too many tests, we'll run the thing and we'll double check and we'll see what we've got. So we check to see whether or not the initial setup worked, whether or not you could brake just once, if you could pedal just once, if the speed increased. So we're starting to get a whole suite of tests here. Okay. Anything else you want to?
Can we slow down more than once?
Well, the first one is, can we slow down at all? More than just 1. So now we'll check to see if braking works. So we'll make our brand new bicycle, and we'll check to see whether or not braking decreases. So we'll make our new bike, and what do we want to do here? Oops, missing a brace. I think we'll pedal a bunch of times. So now what I'm going to do, I'm just going to do my bike dot pedal, and I think I'm going to do that a few times. So there's 4 times. And then I'm going to start braking. So let me borrow the braking code. And then we're going to start braking. What speed should we be going at? 3 since we braked once. So notice you're already calculating. So the thing that's missing is I'm going to take this line and I'm going to put it up here to say I think that at this point speed should be 4. And notice that there's 4 pedals and there's the number 4, and so now I'm emphasizing the point that I know exactly where I'm starting out. Before I wrote that, it wasn't clear where I was starting out because I did 4 and then took away 1. There's a calculation. Okay, so if I brake, now the speed should be 3, and if I brake again, speed should go down to 2. If I brake again, the speed should go down to 1, and then eventually the speed should go down to 0. Okay? And notice the pattern emerges. And it makes perfect sense. There were 4 to start with, and then I should go 4, 3, 2, 1, 0. This is another test you can show your mom, and your mom will go, yeah, I got it. Why didn't I write loops? I just sort of gave you the answer.
They're a lot more confusing.
They're a lot more confusing. You know, can you explain a loop to mom? Maybe, but it's going to take a little work. Can I explain this to my mom? Look, I started out, I pedaled 4 times, I went 4, 3, 2, 1. Look, you know, just read the 4, 3, 2, 1. You understand what's going on? Yeah, sure. She sees the pattern. Right? So here's another interesting rule. When you're doing unit tests, the thing that makes life really, really simple is to do patterns and not try to get people to play Mr. Computer and do calculations and do things in their heads to see if it works. Okay? You would never write this piece of code in a real program, for instance in the bicycle class, because your employer would think you were a complete idiot and didn't understand what loops were. Okay? So in real code that's actually going to be used, you write loops because that's appropriate. In unit tests, to keep things simple, it's best to avoid loops and do patterns if you can, because they're almost always easier for people to understand. Okay? So try the pattern idea first, and if you can't get a pattern to come out of it, then you can resort to doing loops. Okay, so let's run this thing and see what happens. And we now have all of those tests passing. Okay? If we look at these tests, is there something that's common in all of the tests? What's the thing that we do at the start of every test?
Bicycle, my bike.
Make a new bike. Okay, so we've got some stuff that repeats over and over and over again, and it's really just, interestingly enough, setup. Okay, and after a while it starts to make the tests harder to read because you're doing the same thing over and over again just to get the test started. Okay, and so what you can do is you can take the common stuff, which is that particular thing, and you can throw it up into the setup method so that it's common to all of them. Almost. The only problem with this is that I made that bike variable between that set of braces, so it's only visible, it only exists for that short lifetime between that set of braces. So what I'm going to have to do instead is move the definition of the variable, just this part, up above where it can now be seen by the entire class because it exists within that full set of braces. Okay? So we'll move the definition up, which means we don't have to define it, we can just initialize it there. And now, since it's already been defined, you can start to, don't even have to use it there anymore, don't even have to make it there anymore. Notice that my bike is referring to that bike that was declared up there. Okay? What about the next one down? What's happening here? What's the difference between this one and that one? Same thing or different things? Same name, different variables. And the reason for that is that this one inside the braces is the declaration of a brand new, fresh my bike variable because it has the word bike on the front. So this hides the fact that that other one is there earlier. So it's roughly, there used to be a Daryl in the class. When I come in, I'm the only Daryl in the class. The other one is sort of hidden away for a while until I leave, and then it's like, oh, okay, I can see the other Daryl because I'm the important one. Okay? Works exactly the same way. Okay? So you have your choice. Sometimes this makes sense. Sometimes you say, I don't want to use the other my bike variable that was already there. For instance, maybe I only want a 15-speed bicycle. Happen to have called it my bike, who cares? That's a different bicycle, different set of speeds that I'm only using for this little test, and then it's gone. Okay? So there's nothing wrong with avoiding these and making your own later on when you have some special circumstance. It would be helpful probably to change that variable name because this is just going to get confusing. So in the long run, rather than calling this particular one my bike, I should probably call it something like, here's refactor rename again, I'll call it 15 speed bike. And notice you can see also what refactor did. Refactor only renamed this one because that's the total time that that one is around. Okay? But notice how easy it was to use refactor to go, I want to separate out this idea from that one. Okay? So either way works. This setup method tends to get a little bit complicated because quite often it will do different setups for different tests. So I might have, a setup for a 3-speed bike, a 5-speed bike, and a 15-speed bike, and then I'll use them in the different tests later. Okay? There's no magic rule about when do you use the setup method versus when do you don't, other than you don't like to say it's complicated, right? So again, with unit tests, simpler is better. If it makes more sense to simplify things by extracting stuff out and putting it up top, then you do that. If it starts to get confusing because you have to keep going back up and referring to some stuff, then sometimes it's better to repeat that stuff inside the test just to make it more obvious inside the test. Okay? So it's really the scratch your head rule. What's making the most sense to you, what's going to make the most sense to other people to make it work. But that's how the setup method is used. Okay, so there's a sample setup method all set to go in case we need it later on. Okay, so another use for a setup method, by the way, is I might always want to start with a bike that's going at some speed, so that I can do a bunch of tests to see what happens if I go up or go down from some intermediate speed. And so it would make more sense if I were doing a whole bunch of tests that did that to just make one bike in the setup method that was already going the speed I wanted and go from there in the tests. Okay, so we've got a bunch of unit tests. We'll just run them again just to make sure they all still pass. And we can move on to talking about other things about the bicycle. So, now we get let's talk about situations where we've sort of got the bike working now, and it seems to be doing what it's supposed to do, but now reality sets in and people start to do bad things to our bicycle. So in this code that we've got, what's the most obvious thing that people shouldn't be able to do? Oh, we haven't got change gears yet. Just with the variables we've got, what's the one that looks a little suspicious?
Brake can go less than 0.
The current speed could go less than 0 when you brake. Okay. Is that a reasonable thing to have happen? Okay, so now this is now we put on our rose-colored glasses and we said, oh, well, we'll just let speed go up and speed go down and nobody would ever abuse the bicycle. And now somebody's trying to do something that they shouldn't be able to do. Okay, so now's the time when you start to do the worry, not before. You get it to work first, and then you start to worry. So the worry is, oh, I don't think this should be able to go below 0. What should we do to fix that?
If statement.
Nah.
You should put a
Close.
restriction there.
We should put a restriction, but before we put the restriction on it, what should we do first? Where should we go? Not here, but not to the driver, but let's write a unit test first, okay? Because notice that what I'm doing is I'm saying I expect it to behave in this way. So the best thing that you can do for yourself is start to get used to the idea that as soon as you want it to behave in a certain way, you should write a unit test to see whether or not you can produce the behavior that you want, and then worry about writing the code afterwards to see whether it matches the behavior, okay? So let's go in and write a unit test. What have we got here? Braking decreases, speed increases, should be able to brake once. Oh, look. We've got a test that's actually pretty close already. Instead of brake once, it should be no braking below 0. Does that say what I want for my test? Okay, so the good name helps there. So I've got my 21 speed, I'll increase the speed, I'll pedal, and then if I brake, I should get down to 0, and then what? If I brake again,
Or you shouldn't be able to go below 0.
And then your speed should still be 0.
and if I check the speed again, the speed should stay at 0 or still be 0. Obvious test. Went from 0, 1, down to 0, should stay at 0. Any way I can make that test clearer? I might actually put in the 2 here, just to go 0, 1, 2, 2, 1, 0, 0, right, to get a little bit more of a pattern, because I see a lot of 0s and 1s here that are sort of confusing me a little bit. But for now, it's not bad, okay? Speed starts at 0, goes to 1, it drops to 0, it should stay at 0. Got it. Well, now let's run the test and see what happens. Oops, the test failed. What failed in the test? Double click on it, it got all the way through and it hit this last assert statement and the value's wrong. Gee, I wonder what value is there. Let me just put a breakpoint on that assert statement. Let's now run with the debugger. Debugger says speed is -1. Oops, it's not supposed to go to -1. Notice how easy it was to see what was happening with the debugger? Just put the breakpoint on the assert statement, look at the value. Okay, so now we can fix things. We'll go back into the bicycle. What should we do there?
Mistaken.
Put on some restriction. So we said that was an if statement. How do you want to write the if statement?
Current speed greater than
If current speed is,
greater than 0.
no, the opposite.
Greater than or equal to. It must be greater than or equal to 1, actually. Because you wouldn't want to do anything weird.
So we
You wouldn't want
could,
it being a non-integer in the first place, or if you do, you want it to, if it is a non-integer, you want it to jump to 0. So.
maybe that. Maybe that. Notice that we've got all these 25 odd brains engaged worrying about, is it 0, is it 1, is it less than or equal to?
But where are we going to?
Well, we'll get to that. We'll get to the different way.
What's up from ending up at minus at -0.5?
Well, okay, so here's the thing. In previous classes, you were taught to play Mr. Computer, and in playing Mr. Computer, you're sitting there going, oh, okay, I need to get a pad and a piece of paper out, and I need to think, well, if it's this already, what could be this, and this if statement could be this and that, and you're basically having to do all the brain work yourself. Guess what? You don't need to do that anymore. The short answer to this puzzle is, I don't really care, because I have a test that will tell me whether it works or not. And so I can run the test, and the test says, yes, it works. And so I really just stopped worrying about what the code actually said. We'll go back into the bicycle just for fun, and somebody said greater than or equal to 1. Let me do that. And the short answer is, oops, switch over to the bicycle test, run that thing. Oh, look, that works too. Guess what? We don't have to have an argument or a discussion anymore and sit here for 10 minutes amongst all of us and try to convince people whether or not it's right. Okay? So there's another joy of unit tests. The unit test will tell you if it's right. So you can write the crappiest code imaginable, and in some senses it doesn't matter as long as it produces the correct result. There are two different issues. One is, does it work? And the second question is it beautiful inside? People can be all twisted up inside and they can still perform normally during the day. Don't know, right? So it's exactly the same thing here. If you've got the unit test, don't have to care. Okay? So one of the reasons for writing the unit test is as soon as it works, you go, yeah, it does what it's supposed to do. Okay? We can always start to argue, and I can start to say you could have done that better, or you could have done it prettier, or you could have done it more efficiently, but you have something that works. Okay? So now that we know it works, now we'll go back and we'll have the discussion about, is that beautiful? Okay? What do you think I don't like about this one?
You want to have the current speed as default?
What was the number that we thought was important?
0.
What number shows up here?
1.
So right away, we're trying to have a discussion about what happens at 0, and all of a sudden, we're talking, where did this 1 come from? Shouldn't we be talking about 0? Okay? So another rule is, if you're talking about 0 and you mean 0, your code should say 0. Because in general, if your code says what your brain is and what you're talking about, you'll produce a better answer by writing exactly that code. So just for that reason alone, if you want to talk about 0, say 0. Okay? But we've still got an issue here, because I'm not interested in what happens with greater than 0. I'm sort of interested in what happens with 0. And you could say greater than or equal to 0 to try to send that across, but meh. The other problem with this is that notice that what we've done is we've hidden the most important thing inside the if statement, which means that now everybody's going to have to read the whole if statement to find out what's going on. So let me just change this a bit. Let's just go back to what we originally had. That was the rose-colored glasses scenario. Speed just goes down. And let's take this and let's think of a reason why we wouldn't brake. If current speed, I'll do a control space. Current speed, oops, let's use the right variable. Current speed is exactly 0. If it's already 0, what would happen? Nothing to do here. You can't possibly be braking, so we'll just leave. Stop right there and get out. Okay? So notice what happened here. This thing's, the important thing is still sitting out where you can see it. If you don't care about bad things happening to you, you don't have to read the if statement. So the instant you look at this code, you can ignore a bunch of code and you can now go and you can look at the important thing. Versus the other way, you were forcing me to read code to figure out what was going on. And the other thing we said is that we said if we were talking about 0, we wanted to say exactly what we were talking about. And that statement says exactly what we're talking about. If we're exactly at 0, this is what we have to do now. We don't have anything to do. Okay? And I'll say this same thing about the little trap I set for you in Lab 2. The trap is the way that you were taught to do things was to make them complicated with if statements that tried to control bad things from happening, and people are getting all twisted up when they're writing Lab 2 about how do I make this stuff work. If you follow this process of ignoring everything about where I'm going, oh my God, oh my God, oh my God, and you just concentrate on how do I make the thing work to begin with and forget about all the bad things that can happen, you can always go find a way to restrict the bad thing from happening later. And by the way, this is exactly how people work in real life. You don't implement rules and restrictions until you get caught. Somebody comes along and does something bad to you, and then all of a sudden the next time around you've got this barrier in place to prevent that from happening. So you sort of start out assuming that things are going to be good, and then you supply the rules, and every time somebody does something bad you put another rule in front to prevent stuff from happening. So we're playing exactly the same game here. As we experience things, we're finding more ways to protect ourselves from bad things happening. Okay, so there's brake. Questions about that? We can still run the unit test since we've changed the code, and we'll just double check and see whether or not it works, and it still works. So now you've got 3 different ways of writing that if statement. Any of them will work, and they'll verify that it now works. Okay, but one of them is more beautiful than the others. Okay, back to the bicycle. We're now, looks like we've pretty much done everything that we can do with speed. We've got get current speed. We've got it can go up, it can go down. We've made sure it stops when it goes down. What about maximum speed? Should we find a way to restrict maximum speed?
You want to go to 1,000 or something.
What's the maximum speed for a bicycle?
Depends. Depends what you're doing.
Yeah, the funny thing about things like maximums in real life is every time you go and you put in a maximum, somebody will probably find a way to beat it. which would mean all of a sudden your bike wouldn't be sort of quite true to life. So yeah, today I can say, well, yeah, maybe the maximum speed on a bike is, pick a number, so many kilometers per hour, 100 kilometers per hour. I can imagine anybody doing anything faster. We'll look it up, we'll find the maximum land speed in the Guinness Book of Records. You can just bet that even if you double that sooner or later somebody's going to come along and beat it. Okay? So this is pretty typical. There's quite often a lower limit to something that's really obvious, and the upper limit you can guess, but sooner or later your program will probably break when it reaches that, when the upper limit no longer applies. Okay? So the safest thing to do is just say, well, I don't know, leave the upper limit off. Okay? So I'm not going to put one for the upper limit. Now we've got our bike. What other things can you do with this bicycle other than brake and pedal?
Just recommend something out.
Well, just with the variables we have. Brake and pedal really only took care of changing the speed. You should be able to shift up and shift down. If you've got 21 gears on the bike, right now we're only using one. And by the way, notice that you used good words, so I can write, everybody knew what they meant. I can write public void shift up, and I can write public void shift down. Okay? So, how about writing set gear?
You need to start with gear.
No.
Set current gear.
You have to change gears.
I don't think so.
If you sort of think about how bicycles work, people, when they're thinking about them, think I'm going from gear 1 through to gear 21. It might be a complicated mechanism, but it's not, in that mechanism, it's not possible to basically do anything other than go up by gears. You can't go from gear 5 to gear 17 arbitrarily. Okay? So there's some sense that you have to work your way through the gears, even though that's technically not quite true. It's a better way of presenting the problem. Okay, so I'm not going to write a set current gear because it just doesn't seem like it's a reasonable thing for a bike to do. Okay, so what happens if you shift gears?
If you shift up, you go up again.
So what changes?
You accelerate faster.
What's missing here for information?
Current gear.
Current gear. So there's this notion that you're in a current gear, and when you shift up, the current gear goes up. So now we know that not only do we need to keep track of how many gears are in the bike, but we also have to keep track of the notion of current gear goes up. And if you shift down, current gear is going to go down, and that means that I guess I need to keep track of current gear. Okay, so there's the logic in how that evolves. You can start out and say, I need a current gear and I guess I have to change it, or you can work backwards and go, well, shift up must change current gear. Okay?
And you have to put in, say, bicycle.
So-
gear equals something.
Yeah, so now the issue we have is if you add another variable in here, you should make a point in the constructor of initializing it. What's value should it have?
1.
See, this is a sneaky one, right? There is no gear 0, right? And if you just sort of said, oh, okay, I'll let the compiler do what it should do, you would get the wrong answer. So current gear might as well start out at 1. Okay? And this is basically saying, when this bicycle comes from the factory, I expect it's going to be in gear number 1. Okay? And so somebody at the factory is going to adjust it to make that happen. Okay? I had my house redone, the electrical redone in the house in a renovation, And 6 months after I lived in the house, I went and I looked at all of the light switch plates on the wall, and every single one had the screw slot adjusted so that it was, they were all in the vertical position. Every single light switch in the house, every single wall plug, and I went, wow, there's somebody who just knew exactly what they were doing and were going to do a good job, right? So it's that idea, same sort of idea here, that you need to make sure that you get all the conditions set up right. Okay, so current gear is going to be 1, it's going to go up, it's going to go down. Let's go into the test. What do you need to do for tests?
Make sure it doesn't go higher than 21 and lower than 1.
This is a little bit of sneakiness. One of the things that you changed was something for when the bike first arrived at your door. And so when you go back and do the tests, you need to go back to initial setup and ensure that it's in first gear, because you were making an assumption about the thing, right? So we'll do int current gear equals talk to my bike dot, oh, we don't have a get current gear. It's not in the pick list. So we haven't written one yet. So we'll get current gear, and I think that current gear should be exactly equal to, in this case, 1. So set the expectations, go back into the bicycle class and say you can both shift up, shift down, and do public int get current gear. Return current gear. And now when you run the unit tests, you know for a start that the bike is made properly. It's amazing how many times people miss that test, and then you get farther on and something's broken, and it's broken because you didn't do what you were supposed to do initially. Okay? So now you can go and you can write another test here. Let's go down to the bottom. Let's do a quick one. Public void. We want to test to see whether or not gear up. And I'm just going to do this once, just to see if it goes to 2 for a start. So I'm going to say, we already checked the current gear as 1. It still wouldn't hurt to recheck it. So I'm just going to borrow the code off the top that checks current gear. I'm going to say I think it should be 1. Then I'm going to do my bike dot shift up, and then I'm going to check again. Current gear should now be 2. Okay, good for a start. Save it, run the test. Double check to make sure that test is actually in there. Oh, why isn't it in there? Doesn't appear in the list. Didn't do the at test. This is one where I'm really surprised the IDE doesn't pick that out for you. It should give you a warning to say you made a function and didn't actually put at test on the front of it. So you got to be really careful about that. And now all of a sudden we'll look and we should have the gear up once test in there, and it passed. Okay. So what we'll do tomorrow is we'll finish writing the bicycle class and a few more tests. Change it so that it can put the restrictions on gear up and gear down, and then we'll be done with it.